appreciate you guys attending this. This isn't something that Brian and I have been working a lot on with a lot of different people. And just so you know who you're talking to, my name's Caleb Funk. I'm an engagement engineer with IMAGINiT. I've been with IMAGINiT since 1999. And I've been working almost exclusively with the Autodesk products on the manufacturing side. So Vault, Inventor, AutoCAD Mechanical, all of those different tools. Done a lot of different things, done people management, project management, implementations, training. Had a lot of different roles with IMAGINiT through the years. And what I do now is a lot of what we're doing right now, where I talk with clients about possibilities for extending workflows, new and different ways to do things, whether that involves software or services, training, whatever it may be. So my counterpart with me today is Brian. So Brian, why don't you introduce yourself?
Hey, good morning, good afternoon, everybody. Brian Tuffin here. I'm on the building solutions side of the same team as Caleb, so we have a lot of the same roles. I got my start with IMAGINiT back in 2002, so quite a long period of time here implementing, customizing software. This is a lot of what I do. Talk to clients about different needs, solutions, and helping them develop the right software and capabilities that works right for them. Go ahead, Caleb.
So Brian and I mentioned, we've been around a while. That's one thing we want to take a look at here as we look at our agenda. We're going to talk about a little bit of the history of these tools, kind of where we're at and how we're heading this direction. And then we want to talk about a couple of different BIM workflows. Okay? So one of them is going to be the idea of catalog creation. One of them is going to be the idea of building product manufacturing. That's really kind of the core of what we're looking at, because then we want to talk about extending that. So there's a couple of options we have here. BIM catalog is absolutely a big topic as well, but probably not the core of what we're looking at today. And I mentioned the history of these two, and Ryan and I both go back far enough that this once interoperability meant give me the DWG file. Right? If I needed a detail, if I needed a something from either side, whether I was on manufacturing and I needed to put my documentation, my product line into your floor plan, great, I can do that. If you say, hey, give me those details so I can drop them into this drawing package, easy enough. Everybody's using DWG. We're all in 2D. We're all right there. And I remember when the tools first started changing and coming out a little bit and being more specialized, that's kind of what's led us to here. So on my end, we're looking at the left side there where we've got Autodesk Inventor. That's really the tool that we're talking about today when it comes to this, where we can do a true digital twin of a mechanical device, down to actuators, down to range of motion, everything about it. And this could include all auxiliary tooling for that. It could include whether it's a mold or a die cast component that we want to put in there. We need to capture that, whatever it may be. So Inventor captures it right down to a very fine level, right? We're talking thousands, down to several thousandths in precision. We're talking every little screw, nut, bolt, everything that goes in there, and we can capture it, create bills of material, create documentation for that. The other side, looking over at the right, is where Brian comes in. It's a little different on that side, right, Brian?
Yeah, definitely. When you take a look at a Revit-based environment, and that's what you're looking at right there, go ahead and let's leave it on Caleb's screen for just a minute. When we take a look at the Revit-based environment of it, Revit is really looking at parametric design. What is your design intent? Although manufacturing, we can see all the actuators, all the bolts. That's really not what's important to us. The range of motion is important. The area of operations, the area required for maintenance of that piece of equipment. Other things that are also important to it is a graphic representation of what that product is and any services we need to provide to it. Is there a structural load requirement for it? Is there power? Is there data? Do we have to provide coolant for it? Those types of things become important in a Revit parametric environment.
So we have two different uses effectively for the same type of thing. If I were to take, maybe that robot arm that I have there and it goes into the facility there on the right, this is I don't necessarily want to send all of my information across. We have to have a way to facilitate that and a way to bring that in. And again, old days it was easy. We use AutoCAD. Well, then what happened is once they moved to these specialized kernels, for a while there, this was really difficult. And they did begin, Autodesk has kind of begun to accelerate this, and we've seen this back in Inventor 2016, I could, for example, if I wanted to work in Brian's building to begin a layout, I could bring in a Revit file. I could import it and begin working to it. Then I could export to a Revit family. And that was really all we could do for a while. We could either import the file and then export it. Then they added AnyCAD had been around. It came out in 2020. And with 2021, it was AnyCAD for Revit, where I could use the Revit file linked to my file. I didn't have to import it anymore like I did before. I could, and that meant if the Revit file changed, my file changed. So I still had to have the Revit file locally, but it was possible. 2022, I could export Inventor files as a Revit file. So we'll see that in a little bit where I go through and export it out as a Revit file. So it comes in, I work on it, and then I can send it back out. And in 2023, yeah, go ahead.
2022 is probably the beginning of the new way of doing things. That's when Autodesk really first introduced the capability to generate these families. Revit calls them families, AutoCAD calls them blocks. Being able to transfer data and information back and forth from 2022 to 2022 Inventor to Revit type platform. Go ahead.
Yep. So that was definitely a big shift, and you can see it start to accelerate. I mean, nothing happens from 16 to 21, and all of a sudden we're seeing new features every release for this. In 2023, we go a little bit further. AnyCAD, it's still kind of AnyCAD. It's a data exchange, and I'll have Brian explain that just a little bit when he jumps over to some of his stuff. But a data exchange allows me to actively integrate with his project in the Autodesk Construction Cloud and bring that information in as a background for me to work on. So Brian, I know there's a lot there with Revit interoperability, BIM exchange, all these different things. You kind of just explain some of that a little bit.
Yeah, definitely. With 2023, we first got introduced to being able to connect to the Autodesk Construction Cloud, to where I have the ability to share a portion of my design, a portion of my model, maybe a specific area that I'm requiring this manufacturer to develop a crane or a curtain wall or a cladding to go in on the building. That way they're not having to absorb all that information. Now, the beauty of that in the cloud is as I make design and iteration changes, it will update the background that you can use inside of Inventor. So with 2023, we also introduced the ability to generate, instead of a family that I mentioned earlier in 2022, we can generate a Revit project. So manufacturers can now send me a Revit file that has all of their pieces that I can link into mine. And that's really one of the game changer components that happened inside of 2023 and is now carried on into 2024.
Yep, and we'll see some of that, like I said, in just a moment here, where we transfer this data back and forth in a variety of ways. Before we start talking a lot about just transferring that data, there's a couple things I want to make sure we're kind of covering here. One is this one. It's the idea of a BIM catalog workflow. And we are going to generate components inside of Inventor, and we can push them over to Revit. But a lot of times with a catalog, it's a little different. Revit uses, we mentioned families a couple of times. I'll have some examples here. But Brian, could you kind of walk through this idea of this workflow? I know this doesn't even need to have Inventor. Inventor could play a part, but Inventor does not have to play a part for a catalog workflow.
Right, and to me, a catalog workflow is when, as an architect, I can go to your product website and I see a catalog of parts and pieces that are available with different sizes and different options. So that type of workflow lends itself to family creation, being able to provide families out there so that designers can take that information and design with the envelope, within the envelope of the constraints of your product line. I'm not going to go outside of the options of what you're able to manufacture or how that product was intended to be used. A lot of the times I'll use a window as an example. Mm-hmm. We have certain widths, certain heights, certain depths, certain amount of square footage of light that they provide in, of glass requirements. All of that can be natively built in to a family. Well, a lot of you use Inventor. You have that information in your Inventor database. So we can export that out as a family, a separate standalone family that can be downloaded and shared with the designers.
Yeah. So Brian mentioned the idea of a window. To me, when I look at BIM catalog content, we talk about a Revit family, it has multiple types, multiple sizes. There's parameters that can be changed. So it's a product line, length, width, height. I think of things like that all the time. You know, we come up with here's this version of it, a 17 by 24, a 17 by 20, a 17 by 36, all of these different ideas. So some of this geometry could come from Inventor, but I know there's a company that we're working with very recently. We're going to do the design of the components entirely inside of Revit, because just some of the software that's in play, and we're looking at it, and we're like, guys, it makes more sense for us to draw this up in Revit than it does over here. So this is one thing that could be done, this idea of the catalog. The thing that we're going to really address today is a little different. It's the idea of building product manufacturing. And this is a more complicated workflow. So we've got both Revit involved, we've got Inventor involved, and the idea being we want to be able to reference the Revit file and build off of it. In the instance I'm going to be using, I've got some decorative metal cladding that's going to go on the side of a building. And I need to know, how much space do I need to cover? Do I need to change, do I need to adjust this to work around any openings that they might have? I've got standard, 6x8 cladding. Yep, we've got this. This can go out. But do I need to make a new one to fit in with what's going on here? Do I need to adjust my connection points? The only way I can get that information is by looking at the Revit model that we have there. So we're going to use a series of tools for this.
Right, and I would say it's very common to use this series of tools when you're a collaborative process. You develop and manufacture one-off situations that fall within the architect's design criteria, and you need to be working well within that envelope and be apprised of any changes that might happen throughout the different phases of the project.
And I'll say that collaborative process could happen, between companies. In some instances, we've seen it happen within companies where one part of the company does a large layout design of something, and the other side has to manufacture the components that fit that layout. So again, it's collaborative effort. That's what we're looking at, and as we're sharing this information back and forth between each other. And so some examples of this, it's typically engineered to order components. They can be created in manufacturing tools. It could be exported as individual families. They can be exported as an entire set. And we'll show kind of the difference here with how those come together. If you have Inventor properties, those can go along with the family and they become BIM information. So BIM, it's been around for a long time, but it is building information modeling, right? So we have that idea of information that's going along with that. We can put that into there so it goes out with that. So we mentioned the idea of design and communication and how these kind of come together. A couple of different things that we'll see. I'll be using the idea of suddenly escapes me, data exchange. So I can have that data exchange. Brian's created one for me already. We did some of the cooking show things where some of this was already pre-baked in the background. And then we're going to pull that forward so we can use that. And then we can, we'll also go through and do some of these different pieces live as we go through. But we'll see a couple of these things live. Some of it's done in the background. One thing that we're doing is that I don't get into, and we debated it, how deep do we want to go? Autodesk Vault can be part of this workflow as well, where Autodesk Vault does some of the syncing for us. And again, there's a range of ways this can be implemented. And that's one very fun challenge that we run into is someone says, we want to do this. We then have to say, great, what does that mean for you? How do we integrate this? How does this go through? And so, we kind of looked at this as, so let's hit the high points. We're going to leave some of these different nuances off of there, but it is definitely possible to use Vault through that. So what I want to do is we're going to kind of follow this idea, taking the exchange, pulling that exchange information in, building off of it, and then sending that information back so that it can be consumed in Revit. So I'm going to go first. I'm going to pull in here in just a moment Brian's data exchange, work with some information off of that, create some components, and then be able to send that back to him so that he can import that into Revit and we can see it on the other end. We're going to do it two different ways. We're going to do it as a family and we're going to do it as a full set. We're going to take an entire Inventor file and send it out as a Revit project, an RVT file. So I'm going to jump in here and take a look at my portion, and I'm going to go grab my Inventor to do this. So this is the portion that I brought in here. You know, as we're taking a look at it and bringing it in, I just want to show this. This is really amazing that it's built in. It's right in as part of Inventor. We have what we call data exchanges. And with the data exchanges, this is something that Brian has set up on his end. And Brian, as I pull this up, can you just kind of talk a little bit about, you've got a large building, you break it down to different pieces, just kind of explain.
Yeah, I've created a very large building with multiple views, multiple sheets, multiple pages associated with it. It exists in the construction cloud, so I've published an updated version. I think then can go into a specific view I want to give to Caleb and assign that out so that all he has to bring in is the information that's pertinent to him. He doesn't have to see everything else. It's just that one piece of information.
This is a big move because now I don't get sent the entire Revit file, right? I get to work on just the portion that I need to work with. So this was a great step forward with how we could begin working on that. Once this is in Inventor, this is an Inventor file. I can act on this as I would almost anything else. So I could, if I wanted to, come in here and begin creating right off of any one of these surfaces. I can project geometry off of these surfaces, there we go. Use all the standard tools I would think of for working with an Inventor file, right? So I'll come in here and say, well, I know I'm going to need this edge. I'm not going to need that edge. We'll take that to start out. And I know I'm going to, I'll begin constructing my component. That would be one option that I would have. I could build directly on top of that so that I can use the framework of what's already there. Any dimensions coming off of that, whatever it would be, I can work within that environment. Now you'll notice too, this is an adaptive, let's say 10 inches off of there. This is an adaptive sketch that I have. If Brian makes a change on his end, it updates on mine too, right? It comes right through and updates on this end. So I've got it over here. And I'll just give that some thickness. This will be the beginning of some cladding that I'm creating as part of that. I'm going to actually jump out of this and use the other side of it, which is bringing components in. I could begin assembling off of this. Maybe I've already got something created that I want to bring in and assemble in place within here. Again, I can assemble right to his information. This is using all the standard Inventor tools that I would normally work with. I can begin putting that in, locking to it, linking it up. It's going to work very much the same way as it would with any other piece of Inventor geometry. It just so happens that it's geometry that we'd have with, it's Revit geometry that we have as part of that. Okay?
I think one of the amazing things here is that if I move the wall as a designer, Caleb's going to get notification that that link is out of date. He'll get an option to refresh the link, and it will maintain those rules and relationships he's put together. That's really amazing.
So I can use this as, my beginning points to lay out geometry, to link to this, to begin to set this up. And then I can go a little further once I kind of get this, I'll just jump over here to where I want this to be. I can take that panel and flesh it out. So I've got all of the, started the basic shape that I had, began laying it out, getting some sizing that I needed, open it up, put it into a separate assembly, begin to put in all my bolts, nuts, screws, all of the things that would make this component necessary that I would have. Once I have all of this, there's a couple of ways that I can send this now to Brian, and we're going to play around with both of them here. I'm going to show you from my end. I'll take the panel, and I have an environment that I can go to, just called BIM content. And once I come into here, there's a couple things I'm going to set up first, and then I can just export this as a Revit family, one of those Revit families we were talking about just a moment ago. So I'll come in here and begin, I'll say I want to author these components, and I could determine my insertion point. And there's some things, there's a little nuances that are different from Revit to Inventor about how we want to put these things in, but I set that up. Some of the key pieces that I have here, One of them is this idea called omniclass, and this was all new to me. So Brian, can you explain a little bit what this is?
So a lot of your architectural firms owners will be familiar with the Omni classification. It really breaks things down by CSI divisions of what every single product is. And it's going to allow us to directly tie your product to a specification inside of there. Typically manufacturers, this will come from your marketing team or engineering team will know where your classification is. Equally, and sometimes more important than that, is going to be the manufacturer properties or the modeling properties and metadata. Being able to add your specific information that really sets you apart from your competition. That's why you want to be spec'd in a project, being able to automatically bring that data across.
So with this is all of the I properties that we have. We can take these I properties, pull this information, send it across as it suddenly becomes BIM information that can be, it can go into schedules, it can be viewed within the Revit model. All of that becomes, it goes along with it and is built into it. So typically I would set that up first, and then from here, for me, I can just say, save this as a Revit family. It's going to save it out as a Revit family. In my case, I'm going to drop it into a shared project that we have, and we'll switch over to Brian here so he can take a look at what it looks like to bring that particular file in and have that accessible in his model.
Excellent, thanks, Caleb. I'm going to go ahead and share my screen here. You should be seeing my Revit screen right now. So I have a couple of different options here. I'm inside of my Autodesk Construction Cloud. I went out to Caleb's manufacturing folder that I gave him permissions to. Keep in mind, you don't have to have access to the architect's file. And I notice I've got a panel.ipt exchange that's a RFA, a Revit family. This makes it very simple for me to start using. So very simply in Revit, I can come out to my components and choose to load a family. From here, I'll just go out and find that family, select it, and go ahead and open it up. I happen to have already loaded it here. You can see it in my selection set, and you'll notice that I've already got it attached to my cursor. Now, one thing about doing it this way, it's a one instance basis. So I'm placing one at a time. And from here, I would just come in and snap wherever I wanted that product to be placed. It's a one-time snap process with it. I've got mine rendering, so some rendering materials are coming through with it. You'll also notice that I can copy these and place multiple throughout. I do want to point out that that metadata is encapsulated inside of it, and all of this information can be scheduled. So one of them was phase of the project, whether it's signed off, conceptual design, iteration 1, 2, 3, all of that can be done. Now, when we're looking at individual families, there's a couple things you want to take a look at it. I'm opening mine into what I call my family editor. Family editor is starting to show me that, wow, Caleb's got a lot going on here. Look at the bend radiuses of the metal. There was some holes here. He went ahead and removed that. We are seeing the perforations inside of here. But we really want to pay attention to the level of detail and how much information is being brought in as a family so that the architect can easily work within that envelope. Right now, we're pretty good on this one. I'm pretty happy with this one. I'm only going to have 3 or 4 of them. If I was cladding the entire building, I might want to change that to show a little bit less information.
Yeah, we could go to a much simpler representation of that for sure, but
exactly
what we have here is where we'd want
exactly. Because remember, the space it takes up is what's important. The design is what's important to me, not how it's manufactured at this point in time. Caleb, I'll let you take it.
Yeah, so when we take a look back here with what I have is I'm going to go a little different. So in this case, I created my single panel and sent it on out, right? Based off of information that Brian had sent me and that we're working with here collaboratively on, I've taken that information and sent one out. I'm going to do it just a little differently, where I come in, and in this case, I've got a, I'm going to turn this wall off, but I'm going to turn it back on. This is the same thing that we saw earlier, where I've got my wall, but I went ahead and put in. I have now, instead of handing one off to Brian and letting him determine where it goes on the building, I said, no, I'm taking your information and I'm setting up where they need to go. This is how these would fall in order, and this is where they would fit together. You know, we can have a clear understanding of how that works, how the clearances I need, the spaces I need, whatever it would be. So I've built this series of these up now. The great thing is I don't have to send them one at a time. Okay? I can, and there's sometimes instances for that, but in my case, I'm going to send this as one group, which then can be imported into his larger model. And the great thing is this is really simple. It's just export, right? I can take and I can export that out as a Revit file directly for him. And what happens when I do this, you know, Brian mentioned, man, there's a lot of information in here. I can see all of this and all these pieces. I can now come in and I can go through, and I'll go here with my view, so it's turned off. And so I've got my view in place. I've got my information where I want it, and I can now come in and I can determine: do I want to remove holes? Do I want to remove fillets? Do I want to remove chamfers, pockets, tunnels? What do I want to remove from this model? So that way I can clean up all of this information that's there so that it's a smaller model overall. I determine where I want it to go. You know, what does this look like? Where's it at? And then I can just send that out and save this out for him. So in this case, I can create this Revit project that will be appended on his side. When we take a look at Brian's screen here, he'll show how that can come in and where he can bring that in at.
Yes, definitely. So I'll go ahead and open up and show you what that looks like. Oh, there we go. So you should be seeing my project here. So taking a look at the construction cloud, Autodesk, Caleb's already sent out, this is the third iteration of the panels inside of the cloud. I can go ahead and open that directly inside of Revit here. Go ahead and maximize my screen here. And you'll notice he's placed these 5 panels inside for me, so I can start to see what's happening. There might be 300 panels laying out the entire exterior cladding of this building. Now I can see it, and it has a common insertion point. So really, all I have to do back in Revit here is go through and insert, and I can link a Revit file. I've already linked that file in, so I'll just take a look at Manage Links. And you can tell right now it's coming from my cloud environment. It's treated as a linked in Revit model with a different level of detail that Caleb went ahead and determined early on based off of, you know, the level of detail of his shrink wrapping of how he brought it in. Now, one of the benefits for me of this is the file size is not going to have an impact as much as each individual family. I don't have to place them around, but yet I get the distinct ability here to start to take a look at this and realize, oh gosh, Caleb, what were you thinking here? I want the joints to line up perfectly with the doors and the windows here. So I want a smaller panel, larger panel, probably 2 equal smaller panel, and maybe a larger panel here. I can either convey this with some geometry or lines to help him understand where he wants it, or I could even go back to my construction cloud here, take a look at my Revit project and open up inside of the construction cloud and mark it up for what my requirements are. Go ahead, Caleb.
Okay, so everything that we've done to this point is very much out of the box. These are tools that are available to you today as part of either, you know, with Inventor, everything that I've done, nothing was fancy, nothing was special. It's just tools that are available within Inventor that we can use. You know, you can turn around and use them right now. Same thing is true of Revit. Revit can pull that information in without any additional configuration, without any additional setup as part of that. What we want to do is talk about the idea of kind of a third alternative, right? Not just Revit families, not just having the, you know, the entire Revit project, but using a transfer engine. Okay, so just so we're clear what I'm talking about, this is a software bridge. This is custom software that's written to work with Revit and Inventor. And this is something that IMAGINiT has done a fair amount of lately. This topic has come up again and again. Brian and I were just saying earlier how many, we're not sure how many of these types of presentations we've done, and the number of discussions we've had, it's pretty substantial. This is a common topic. How do I take information? How do I leverage Revit information, or how do I send my information to Revit? Well, what we're seeing is some companies are opting for this idea of having IMAGINiT create this custom software that allows for different things. And for example, we can pass geometry, not CAD files. So geometry would be, just give me the points, give me some planes that I can begin working with. I don't need the Revit model, I just need the points so that I can begin building off of that. We can automate, there's the idea of validation of design to fabrication. So we can validate, before we go through, we can run rules to check on things to make sure it's accurate. Automatic creation of Revit files, automatic creation of drawings. And then the idea, once we've got this, where it exchanges, is we can have interactive, true interactive, not just reactive. Not I sent something like Brian goes, oh, this is wrong, let's look at that. But we can interactively collaborate on design changes. What's interesting is a lot of this is happening within a single company, where there's a company who maybe receives Revit files from an architect or creates their own as a layout, but then has to manufacture to that. The idea of a transfer engine, which is just automation, it allows this information to work. And here's some of the things that we've done with it. So Brian, from your end, I know looking at kind of the Revit side of that and what's available over there, what's some of the things you've seen from that end?
A lot of the times I'm working with companies that are dealing with curtain walls, custom interior wall cladding components, exterior cladding components, or maybe even some very complex ceiling type components or stairs, allowing me to design a basic concept for the stair and transfer to the manufacturer the key code requirements or the key design requirement areas, and then allowing them to go beyond that and fully develop it in Inventor, transporting that data directly back to me.
Yeah, and in the Inventor side, it's the idea of receiving that information, but then it goes a little further to automatically creating some things. So for instance, production drawings, I create these panels, they're all laid out the same. They need to go in this orientation. We need to have a DXF so we can send it to the laser, and we need to have a detailed drawing showing up like this. But and they're all pretty much the same. We can automate.
Even understand what area, what wall this skid of panels goes on, where it goes in the construction process, how you're delivering it.
That's a key one to me. That idea of I just wrote it in here as tag similar geometry. We can tag things such as this is wall 1, this is wall 2, or this is phase 1, and those types of things that we can see tagged on an architectural model that do not show up on manufacturing because the worlds are so separate. We actually have been able to tie those together in a variety of ways, and that's definitely one that we can do. And again, the similar idea of extracting reports, right? Being able to pull BOMs and schedules, not just from a single Inventor model, but for all the models that would go into a building, or from the other side, pulling schedules out of Revit. So I'm just going to show as a concept some of the ideas that we could work with. I'm going to jump back here to my Inventor. This is something that I was pulling in actual Revit geometry here and building off of that. But like I said, it's very possible that I may not want to go quite that far with it. I may just need to pull in some different pieces of geometry, and of course I've lost that piece. I can pull in different planes that I would have as part of this, so that we can have some of that information in there. And we don't have to have all of this extended information as part of that. It could just be a series of planes. A big thing that we can do once we transfer that information across is begin to work with it on this end, where I can begin to automate the different pieces that I have, where I might say, all right, let's build this up. I've got a specific length, a specific width, a specific thickness, choose different mounting kit options of how I'm going to work with that. I'll say, yep, I don't need a BOM off of this one, and I don't need a Revit family, but go ahead and give me some detail drawings. You know, let's build off of that. And again, we're leveraging code in several different ways. It could be something as simple as a configurator, like what we're seeing here. It could be to things that are more complex, such as leveraging Autodesk Forge, which is effectively allows us to run things in the background to automatically generate different things, such as my drawings. You know, where it goes through, once I hit OK, it builds up the drawing, gives me the orientation that I need, you know, begins ballooning that out, pulls out a bill of material as part of that. Looking at a whole project, all the components that are there, depending what information we pass back and forth. So we've done things as simple as just passing geometry back and forth, and things as complex as go through, grab every opening that I have in here, give me an analogous version in Inventor so that we can build off of it and push it out. So there's a lot of different ways we can leverage the same type of components and the same type of geometry to put this in. Brian, do you have anything to add to that? That it's kind of it's a difficult concept to get across because we haven't written your software yet. It's possible, we can do it, but I can't show it because it's not written.
Yeah, you know, it boils down to being able to better convey the information back and forth across the two platforms. Inventor is amazing for manufacturing, for fabrication, for the high-end detail side of it. Revit, a lot of the times I'm seeing people are using for the design and the installation drawings. So maybe I want to be able to tag which part numbers are used where in which area. You know, we're fabricating it, we're putting the skids together, we're manufacturing it, we're shipping it, but we want to use Revit to tag and schedule what needs to show up when. That's another prime example of it.
Yeah, it's a great example for what we'd be looking at. So, but yeah, that's those concepts, those ideas, you know, whether you're using the standard tools available within Revit and Inventor, or you're looking to extend those through automation, where we can, you know, read the geometry and automatically begin generating things within Inventor. You know, all of that is definitely possible within the tool sets that are available to us today. So that's kind of the big broad overview that we wanted to show. I want to open it up to see if there's, you know, I will say I'm guessing there's questions, because this always generates a lot of different discussion points in here, whether you're on the Revit side or the Inventor side. There's a lot of ideas being expressed here. So I just want to open it up to Lori.
And as we're opening it up to questions, I'd definitely add that, you know, Caleb and myself have a lot of conversations that are tailored to each individual manufacturer. We're more than willing to jump on a call and talk to you guys about it and how this might have an impact for you.